All right, to finish off this video, we're going to do kind of a little bit more advanced stuff. We're going to be problem solving a little bit more with our formulas, and we're going to be talking about what's called a composite figure. And a composite figure is just a bunch of smaller basic figures that are added together to make a more complicated figure. So we'll start off by looking at composite figures by using a trapezoid, because the trapezoid is actually just a combination of a rectangle with two triangles, sometimes just one triangle, but in this case two. And so what we'll be able to do to find the area of this trapezoid is we could find the area of the two triangles, which we now know how to do, find the area of the rectangle, which we now know how to do, and we could just add those together. Although there is a formula, and I give it to you on your reference sheet here. To find the area of a trapezoid, there is a specific formula for it. So we'll do it both ways, just to prove that they're the same. And then we'll do a couple more practice with some composite figures to finish it off here. Alright, so this trapezoid, to find the area, we could break this up into two triangles and a rectangle. If I want to find the area of this rectangle in the middle, I know my base is 14 and my height is 12. So the area of the rectangle would be 12 times 14, or 168 over here. The area of this triangle, well, I have what I need to find the area of the triangle. It's going to be 5 times 12, base times height, divided by 2. So 5 times 12 divided by 2 is 5 times 12 is 60. Half of that is 30. And one more triangle. We need this 8 by 12 triangle. So how did we find this bottom length of 8 or the side length of 12? Let's talk about that first. Since the bottom full length here is 27, and we know that part of it is 5 here, and another part of it is 14, same as it is across from it. Well, 5 plus 14 is 19, and so to get up to 27 to finish it off, I need 8 more, so this length must be 8. This length is going to be the same as the side opposite, since it's a rectangle, and so this has to be the same, 12. So now I have my base and my height. I'm going to multiply those two values and divide by 2, so 8 times 12 divided by 2, 8 times 12 is 96. Cut that in half and I get 48. So if I add up these three areas, this area is 30 plus this area 168 plus this area of 48, then I get an area of 246 square units. Since the units aren't included, I don't know what they are, I could just put generic units here. Sometimes we just don't include units, although I think it's important to remember that we're talking about square units regardless of what they are, so try your best to just write it generically if they're not provided for you. Alright, so there's one way to do it. That way is called the additive property, or our additive area formula. We're adding up a bunch of individual areas. There is a way to use a different formula specific to trapezoids. What we're going to do is we're going to add the two base lengths, and those base lengths are the lengths that are parallel in a trapezoid. So these two lengths right here are the bases. Those are the two parallel sides. We're going to add 27 plus 14. Then we're going to multiply that by the height of our trapezoid, and the height's going to be parallel to the bases. So our height is 12. And then we're going to cut everything in half. So here's our formula. I'm going to substitute my two base lengths, add those together, and multiply by the height length. 14 plus 27 is 41. 41 times 12 divided by 2 is going to give me the exact same thing, 246. We could do this maybe mentally to help us. It doesn't matter which of these two values I cut in half. Cutting 41 in half is going to give me a decimal, so I'm going to cut 12 in half instead. So this is actually equal to 41 times 6, and I can do that in my head. 40 times 6 is 240, and 1 times 6 is 6. Put that together, I have 246. So there's another way to find area of a trapezoid using a specific formula for it. But remember that we can also use this additive area form and just break shapes up into smaller areas that we perhaps know how to do instead. So we'll do that next. But first, let's finish this off and do perimeter. Again, with perimeter, what we're going to end up having are two unlike terms that we're not going to be able to add together, but we will be able to approximate and round it to a decimal value. In order to find all of the outside lengths that we need for perimeter, we're going to need to find these diagonal or slanted lengths here. We are given this length of 14 and this length of 27, but we're missing these two side lengths. So what we're going to do is we're going to go back to the inside and look at those triangles. They're both right triangles, so we're going to be able to use some right triangle math to figure out the hypotenuse of those triangles. So since we know two sides in a right triangle, we're going to use Pythagorean theorem to find the hypotenuse. So if you remember from the last unit where we practiced Pythagorean theorem quite a bit, to find the hypotenuse, what we're going to do is we're going to square our two side lengths or legs here and add them together. So we're going to find the sum of the two squares of our legs. So 12 squared is 144 and 5 squared is 25. If I add that together, I get 169, and if I square root that, I'm going to get the length of that hypotenuse or side of my trapezoid there. Well, 169 is a perfect square, so when I square root it, I get a nice whole number. The square root of 169 is 13. So this side length is 13. So far I have 14 plus 13 plus 27. Let's find this last side length here. Again, using this right triangle with sides 8 and 12, or legs there. So all we need to do is square those legs and add them together to find the length of the hypotenuse. We'll square root it. 12 squared again is 144. 8 squared is 64. Adding those two things together, I get 208. That is an irrational square root. I cannot square root it and get a nice whole number. My calculator is going to give me a decimal. So I could find the decimal form, and then I could add everything together and approximate it, and I would get about 68.42. If I wanted to keep things in its most accurate form, then I'm going to keep it in terms, radical terms here. So I'm going to simplify the square root of 208, which is another skill that we practiced in that last unit. I'm going to try and factor 208 such that I get one of my factors to be a perfect square so that I can simplify it, pull it out of the square root. So the biggest perfect square that is a factor of 208 is 16. 16 times 13 is 208, and I can square root 16 and simplify that and bring out a 4, and then leave the 13 under the square root. So here's our simplified radical form, the most accurate way we can represent that side length without turning it into its decimal form. So if I add up my like terms here, 27, 13, and 14, I get 54. And then if I just say that I want to add that irrational number to it, that would be the simplest addition form. But again, we could take that to its decimal form and approximate it. All right, so there's the trapezoid. So quite a few shapes there to practice. You have a worksheet on the teacher website to help you practice all of those basic area formulas. But like I said, we're going to step it up one more time here. We're going to get into what are called composite figures. And this is going to help us as we move forward. We're going to get into volume and surface area of three-dimensional shapes. In order to do that, we have to understand our two-dimensional shapes, so make sure you practice these formulas so that we can then apply it to the third dimension. Another thing we're going to do is we're going to build more complicated three-dimensional shapes. Again, those are called composite figures. And so we'll be able to find volume and surface area of some more complicated figures by using a combination of these basic shapes. So here is our introduction to that. And then I've also provided a practice worksheet with these on the teacher website as well. All right, so here's how we can do perimeter and area of composite figures. We can just break up these complicated shapes into our basic shapes that we just discussed. And we can actually use two methods. We can use that additive method where we just break it up into smaller shapes and add up all the smaller areas. But there's also what's called a subtractive method, and I'll show you why that might be useful sometimes as well. You have your choice. You should get the exact same answer either way you do it. So let's try and use both methods here on this first example. So here, if I want to break this up, again, there's lots of ways to do it. There's not just one way. I'm just going to show you one particular way that I chose to do it. You might do it differently. Maybe you want to challenge yourself to do it differently and see if we get the same answer. I see that I have a rectangle here on the right. So if I know that my length times my width will give me my area there, I can figure that out. I'm given 3 as a width here and 17 as a length. So I could find that area, just 3 times 17, and I would get 51. I could then see that I also have another rectangle on top if I draw a little line here. And that rectangle is going to have a width of 9, which is given to me here. And what's my length? Well, my total length here is 25. I'm given 3 and 11 here. That's 14. So there must be another 11 left over to get me to the all the way to the other side. So I have 11 here plus another 11 here. So that's a length of 22. So my area here would be 22 times 9. 22 times 9 is 198. And then for my third shape here, I have a trapezoid. So I have 2 parallel sides. Those are my bases. And I have my height that's perpendicular right here. My height I already knew was 8 because 9 plus something has to get me to 17. Obviously, this is not drawn to scale, but we're going to go with it. So we have a height of 8 and a base length of 11 and a base length of 5. So to find the area of that trapezoid, I'm going to add up my base lengths. 11 plus 5. And I'm going to multiply that by my height of 8. So 16 times 8, and then I'm going to cut that in half. 16 times 4, if you'd like, is 64. And so now I can add up those 3 areas. The area of the trapezoid is 64. This rectangle is 198, and this other rectangle is 51, and I should get an area of 313 square centimeters. So that would be the additive method. Now let me show you why maybe the subtractive method is a little bit more helpful in some cases. If I imagine that this is a filled-in rectangle, it has a length of 25 and a width of 17, so the area of that rectangle would be 25 times 17, or 425. And if I just take out this trapezoid shape from my area, well then I get the leftover area, which is the area of this crazy shape. So to find the area of this trapezoid, I need to find my bases. My 2 parallel sides are 11 and 17 would be the length here, again, because I have 5 and 3, that's 8. So to add up to a length of 25, I must need 17 more there, so that's the length of 17. So if I add up my 2 base lengths, 11 plus 17, and then multiply by the height of this, which is 8, and cut that in half, then I get the area of my trapezoid to be 112. So if I take the area of my rectangle, 425, and I subtract that trapezoid, 112, I get the exact same thing. Slightly less computations, and I get the exact same answer. So it's really whatever you're comfortable with, however you want to break up shapes, and whatever way you can make it easy on yourself to find the area. To find the perimeter, well, I'm missing this diagonal length here. So what I'm going to do is I'm going to find the length there by, again, using a right triangle if I need to. But so far, let's see what I got. I got 25, I got 17, I got 3, I got 8, I have 11, and so I'm thinking that right here I need to find that length. Well, what I'm going to do is I'm just going to redraw this out here just so I have some more room to show you what I did. We knew that the height here was 8. Let's see if we can figure out this length of 6. Again, because I know this length of 3 plus this length of 11, that's 14, plus this length of 5, that's 19. What's left over right here is going to help me add up to 25. So I must need 6 more. So that length has to be 6. So here I have a 6 by 8 triangle, that's my base and my height. If I multiply those two things and divide by 2, I can get the area. Oops, sorry, that's not what I wanted. If I want to find the length of the hypotenuse, let's back up a sec. I need to use Pythagorean theorem given my legs here. So let's square them and add them up. So 8 squared is 64. 6 squared is 36. And if I add those together, I get 100. If I square root that, I get that length. The square root of 100 is 10. Maybe you already knew that because you recognize this is a 3, 4, 5 triangle that's just been doubled. Maybe you didn't need that Pythagorean theorem, but that's definitely a bonus. So now we have our length there of 6, or I'm sorry, 10. Paying attention here. I'm going to add that to my sums going on and then finish it off to go around the shape. I got 5 here and another 17. So if I add up all those side lengths, I get a perimeter of 96 centimeters. All right, one last one to discuss. Again, just using different shapes, breaking them up. We're going to create a triangle, a rectangle, and half a circle here. So I'll show you how to do what's called a semicircle. Here to find the area of our triangle, we're going to do base times height divided by 2. So 4 times 4 is 16. Cut that in half, we get 8. So there's the area of that triangle. Find the area of this rectangle. Since the radius of our circle here is 3, the other side is the same length. That's 3. So that's giving us the length on our rectangle there. So 3 plus 3 is 6. I wrote 9 there, so that's a mistake. Don't pay attention to that. We'll fix that in a sec. So 4 times 6 would give us the area of our rectangle. 4 times 6 is going to be 24. Wow, I really messed this problem up, huh? Hopefully you're doing a better job. So again, the area of the rectangle there is 4 times 6, that's 24. So 24 plus 8 so far is going to give us 32. Let's work on this half circle here. So we know the formulas for a full circle. We're just going to cut those formulas in half, divide our answers by 2. So to find our area of a half circle, we're going to take the area of a full circle, radius squared times pi. Here's our radius, 3. Square the radius, 3 squared is 9 times pi. If we cut that in half, we'll get the area of the half circle. So half of 9 is 4.5. We can leave it in terms of pi or approximate it in its decimal form. 4.5 times pi will give us 14.14 square meters. So if I add that to our 32, and then we get about 46.14. So let's make sure that that gets edited and changed there. All right, now let's find the perimeter of this crazy shape. Let's see what lengths we have and what we need to figure out. We have this length of 4. This length was 6, if I can count correctly. This length of 4 here. We don't know this hypotenuse of this right triangle, so let's figure that out. Again, to find the hypotenuse, we're going to use our Pythagorean theorem. We're going to take our legs and square them. 4 squared plus 4 squared. That's 16 plus 16, which is 32. If I have 2 16s to make 32, then 16 times 2 is my factored form, and I can square root 16 to simplify it. Take that 4 out. So that length is 4 times the square root of 2, which maybe you already knew if you remember your properties of the isosceles right triangle, where we just take the side length and multiply by the square root of 2 to get the hypotenuse. All right, so the last thing we need is just half of the circumference of a circle. So the circumference of a circle would be the diameter times pi, or twice the radius times pi. So there I knew that 3 plus 3 was 6. If I take half of that, because it's a half a circle, well then it's going to be 3 times pi. So there it is in terms of pi, or we could approximate that using its decimal form. All right, so for our perimeter, we are doing 4 plus 6 plus 4, so 4 plus 10 instead of 13 there, plus 4 times the square root of 2 plus 3 times pi. So to add up our like terms, we could only do that 10, not that 13, right? 10 plus 4 would be 14, plus, here's a term in radical form, 4 times the square root of 2, plus a number in terms of pi, 3 times pi. So we could convert those two numbers into its decimal form and add that to our 14, and we should get probably, I'm guessing, 29.1. All right, so there's composite shapes. Just adding up a bunch of our simple figures and just putting it all together. Make sure that you practice your area formulas with those basic shapes, again with the worksheet found on the teacher website. And then in addition, you got that other worksheet with the composite figures, which is just going to help you practice those formulas even more. Again, we're going to use those formulas when we get into volume and surface area coming up. So make sure you get that practice done so we can do that. Let me know if you got any questions. Feel free to email me with anything.